It is the Two Guys Garage Podcast. He is Kevin Bird. I am Willie B. Fired up today because we're talking suspensions, man. We're talking all these things to make old cars cool again. Because I'm telling you, man, nothing wakes a car up like putting new suspension components, parts, and pieces under it. Man, when I mean wake up, I mean drive like they were meant to be driven. Those cars from eras long gone have great lines, awesome personality. They're works of art, but let's be honest, they handle like barn doors, like bricks. They're awful. So if you can tighten that game up substantially, then man, you got something that's just wicked, just an absolute cool combination.
Yeah, you know what? Even with the old stuff, the new stuff is great. It's so much better, miles better. But there's always room to make it even higher performance. So we've got KW suspension guys on. These guys are one of the leaders around the world in dampers and shocks, right? Coilovers of all types to make no matter what you're driving, top of the game. And, you know, I hit up Frank. He's their brand manager. And I said, man, what if we got a little techie? What if we got a little in-depth today? You know, little down in the deep, the weeds and the mechanisms and how it works. Because, you know, we all have, you know, shocks with, well, some of us with maybe one knob, maybe two knobs, maybe three knobs, all the adjustability, right? Compression, rebound, maybe high speed. But what do we do with those knobs, right? How does it work? What's going on inside that shock, right? So you can either deliver one that's non-adjustable and, man, out of the box, they're usually pretty great. And then for us, you know, real performance guys, racers, then you start getting all kinds of buttons and knobs and ways that you can get yourself in trouble or, you know, hit the winner's circle. So we got the crew here today to really guide us and give us some skinny.
Yeah, no joke, bro. You said crew. They brought lab coats. They brought assistants. There's somebody taking notes. Like, there's going to be minutes after this meeting's done. This is legit. I'm excited about having these guys on. I hope we all learned something. So excited to have you guys on. Frank, Chris, Joseph, thanks for joining us today, man. We're excited to have you guys on. Tell us all cool things at KW Suspensions, man. How's life in your world? It's got to be crazy right now.
Yeah, definitely. I think everyone's running a million miles an hour. We've always got these guys, you know, working on all the different motorsport stuff that's coming in, and you know, Joe's handling all the new development stuff that we're working on, and that list doesn't get any shorter, unfortunately. So I had to, you know, kind of, you know, coax these guys into coming in here and sharing some knowledge with us guys. I know we want to get techie, and I want you guys to learn, you know, the questions you're asking for, and Chris and Joe are the guys to make that happen.
Yeah, this is awesome. So we got Joseph. He's from R&D, man. So he's in all the, you know, behind the scenes, digging down deep to engineering, making it happen. And we got Chris from motorsports, man. So this is all about, right, we talked about all the tuning, the dialing it in.
Yeah.
And, man, you would not believe the difference in the right spring and damper combination, right? And the technology that's going in these dampers, these guys can fill us in, is through the roof. Right. And we have, obviously, you know, you can kind of dial into some of these new vehicles, these high-end vehicles that have computer control.
Yeah,
computer controlled. So that's a whole nother dimension. But let's start with some of the basics, right? What's going on in a shock?
Right.
You know, I'm an engineer, but I didn't learn about, you know, too much about shocks, but I know enough to get myself in trouble. And, you know, the thing about a damper, it's trying to slow down a spring and with a mass in motion. And what gets me a little confused, and you guys can dial us in after the break here, you got the mass of the suspension. So that's one thing you're trying to damp. But then you got the mass of the body, and it's a completely different mass, right? And then you got all kinds of dynamics that are happening. So how the heck do you figure out what to deliver in a shock? And then once we get one, what can we do with it? So this is going to be fun, guys.
It's like trying to control one of them old school Sears water beds, man. Remember those things? You hit them things and wave out. You get seasick trying to get off of them.
That's right. You can bump your girlfriend right off the other end if you're not careful.
All right, man. So here's the deal. If damping, shocks, coils, suspensions, if that was a ham, this is a 20-ounce can. This is a 20-ounce ham in like a 5-ounce can, y'all. Honestly, when you're looking at suspensions, so much has changed over, you know, take your favorite era car, whatever that may be. It could be something, you know, modern muscle style. It could be something, you know, classic from the 80s, the 70s, the muscle car era, the 60s, even some of the old Tri-5s, whatever that may be, rat rod style. man, when you get a great suspension under that ride, it becomes so much fun to drive it. Kevin and I have debated our list of what's like the most important things. And I really think suspension's up there arguing and debating for that number one spot, right behind or tied with transmissions. So, having more than the old school 3-speed, having like a 5 or 6-speed, but really, man, night and day changes when your car morphs into, what it was, sloppy, mushy around turns, massive ratios and gearboxes. And all of a sudden, all those pivot points get really tightened up with modern pieces, components, and even eliminating some of that old stuff, going to more modern style rack and pinions and pivot points. God, you could really turn a car around and how it handles.
Yeah, like I said earlier, you can take a newer car that's really got good suspension. It's got all the right bits on it. It's got the rack and pinion, and it does great. But you can put on a nice set of springs and shocks and take that same vehicle and drop a couple seconds off of lap time. So what is happening at that tire is incredible. And it's all about controlling that contact patch, right? That is everything you have, that grip, whether you're cornering, braking, trying to accelerate. It's all about maintaining that contact patch. And so if you get any kind of separation, and you don't have the control to keep that thing planted, right, you're losing time. And that's what that damper and that shock are trying to do, is keep that contact patch the whole way around that track for as much as possible. Now, guys, thanks for joining us, man. This is going to be fun. I think we can get into all kinds of things like monotube and twin tubes. I think really what's cool is that control part. If you go from engineering side of things, right, if you just have a spring with a mass kind of, bouncing back and forth, you need to damp it out, because otherwise it'll just keep bouncing forever, except for maybe some internal friction. So you want to dampen it just the right rate so that, you get, one cycle and you come back down and kind of stop, right? You're not bouncing down the road. And again, you got a mass of the vehicle that could be bouncing, and you got a mass of the tire that could be bouncing. So you guys have a lot on your hands. Could you kind of walk us through, like, how do you parse that up? Then you have things like body roll, right? So, you take a turn and you got body roll, and some of it's kind of quick and instant, if you're taking a quick turn in, and some of it could just, be slow as you're going around a big sweeper or changing radius. How do you guys manage all those different, basically, controls?
Joe, you want to start us off here?
Oh man,
bring it, Joe.
That's a big question, man. We're hitting you hard.
that's a lot to take in, or a big question.
It's a big open-ended question, right? I mean, maybe we break it down a little bit, right? So inside that shock, we've got a piston, and it's pushing on a fluid. And without any holes, tiny little holes, let's say around that piston, you're going to hydrolock, right? You're not going to move. So we drill a whole bunch of holes in that piston so you can push and squeeze, and fluid's going through those holes. And the thicker the fluid, the more resistance. The thinner the fluid, the less resistance. And then you guys can put a whole series of pistons with different holes. And then think about, a piston with a bunch of little holes around the outside. You can put a real thin, round, shim, or they call it a valve, but just a little plate. And as the fluid's trying to flow one way, it can bend that little circle, right? It can just bend it up and let fluid flow. And then the other way, it can close the valve. And so you guys can play a lot of tricks with number of pistons and stacks and shims and valve sizes. But with all that, then how do you break down? Like, you've got shock curves. So maybe start talking a little bit about a shock curve. What makes a good curve, and what do you go for?
Yeah, so shock curves or damping profiles are really just going to depend on the application. So you got things like motion ratio, which is the relationship on how much the damper is going to move in relation to how much the wheel actually moves. You obviously have wheelbases and ride frequencies and tires, what type of tire compounds, what the use is going to be, because you don't want a really high ride frequency and stiff sprung and damped setup for something you're going to drive on the street that's going to rattle your teeth out. That's going to give you optimal performance on the track with racing slicks or something like that. But when you go on the street, that's going to be horrible. So, it really just depends on the application, on what we're trying to do with the damping profiles.
I think there's a lot of fundamentals, like Chris talked about, to start with first. You want to get your spring rate in the ballpark. You want to get your damping to a pretty good, base. And then you take things like the sway bars and all that stuff into account as well. And it's important to remember that all that stuff has to work together as a complete package, right? So it's almost...
So Frank, Chris, how do you, so as you're talking about that, how do you make sure you get everything that works together? How do you make sure your spring rate and your sway bar rate and everything is kind of cohesive together? Because I see a lot of people maybe piecing it together, budgetarily wise, or just as they are able to replace, a part or two. How do you know you got the right things working together? Is there a way to sort of make sure that trajectory remains in these guides of where things were functioning, together?
Yeah, I mean, you could definitely start with something like your ride frequency. There's plenty of calculators online that you can probably find this stuff, and it takes into account wheelbase and spring rates and, the unsprung mass and the sprung mass. So the unsprung mass being wheels, tires, brakes, nothing that's actually suspended by the suspension. And then your sprung mass, which is going to be like the body and everything that the suspension actually supports. So, you kind of start to look for like maybe a target ride frequency.
Yeah, explain that a little bit. So let's just say we pick a vehicle, right? So it's constant. We've got a C6 Corvette, right? Pretty well-known type of application. So ride frequency, explain what that means to the general public. It's essentially, right, how stiff your spring is going to be, right?
Duh, Bert, it's every time you get in your car and drive it, at least 3 times a day, 4 times if I'm lucky. No.
How many times you taking a ride?
I use it both coming and going.
So if you had a C6 Vet, right, how would you explain ride frequency?
Well, I mean, there's everything's going to be a little bit different on each application, and not just talking about vehicle application, but application relative to, again, street, track, drag racing, what tires you're running, because tires themselves have a resonant frequency, and they have, kind of a happy spot for them as well. So, but a general rule of thumb is you kind of hit it on the head. It's the stiffer or the higher the ride frequency, the stiffer the spring rate and all that's going to be. So generally speaking, you're going to have maybe a ride frequency of 1 to 2 hertz on like a street driven car or like a weak car. And then you're going to get into maybe 2.5, 3 hertz, maybe 3 and 3.5, something like that. That might even be kind of high for a sports car. And then you get into, like a formula style car, there may be somewhere around 5 hertz. And that's basically an oscillation. So how many times is the suspension oscillating per second? 1 hertz obviously means 1 time a second. So if it's 5 hertz, then it's going to vibrate, if you will, 5 times a second. And that basically just is, again, the frequency at which the suspension is moving. And generally that's higher with a higher spring rate.
So Willie, that kind of helps to frame your question, right? To start with, you probably want to dial in your spring rate. And that's going to really dictate the characteristics of the car, right? Is it super stiff, right? Is it going to be kind of tight in the corners, right? Is it going to be really harsh on, street driving versus track driving? So I think getting your spring rate sort of set from the very beginning then creates sort of your roadmap. And now you need to start kind of dialing in your bars and your dampers to go with it. Now, damper needs to go along with the spring rate, because you'll see a lot of guys that, might have a little ricer they've cut the springs. And so it's essentially increased the spring rate. And they have the same shocks. And so all of a sudden they have a higher spring rate because they've cut a couple coils off. And now they're kind of bouncing, right? They don't have enough damping to control that, bigger spring rate. So once you set that ride frequency or spring rate, aggressive or soft, now you got to get a damper in that range. So where would you guys go from there? I mean, back to the C6. So let's say we pick a pretty aggressive, track day street car. That starts to set your what's that?
Can we just put a public service announcement out there? If you that guy that's cutting your springs, just stop, cuz. Just stop. Friends, don't let friends cut the springs. Seriously, stop. All right, continue. My bad.
If we're gonna make public service announcements, then we should also add: don't cut your bump stops.
Yeah.
You know, they're there for a reason, and cutting them doesn't give you more travel. The vehicle's heavy enough to compress it. Cutting it doesn't help the situation.
We used
Especially,
to have more travel, bro. Wait.
You always want to worry about travel, of course, but if your wheel and tire is already hitting your fender, you don't have no more to add.
Yeah.
So you can stop right there.
Slow down.
But that's my public service announcement.
Thank you, sir. Thank you, man.
Keep us
Appreciate
out
it.
of trouble, man. It's always good. It's always good. So let's say we've picked our wheel frequency, right? So we've got our vehicle, we've got our wheel frequency. It's spec'd into whatever we're going to do. Let's say performance driving on a track and street. Then how do you dial in the shock? And then are there multiple segments of a shock curve to do different things? Because you definitely have the compression side,
absolutely.
you've got the rebound side, and then if there's a high speed side in there as well. So are those different pistons and shim stacks or different directions? I guess the fluid is flowing for compression and rebound.
Yeah. So just to kind of unpack, because there's kind of multiple questions there.
That's Bird for you. That's the engineer in him, man. You just got to pardon me. Well, I'll keep it simple. Start with the easy shock. The one's got one knob with 3 settings. Click, click, click. Well, what are those? What do those do? And then you got to go to another shock. It's got 2 knobs, 3 settings apiece. What about those? And then on up to the 3 knobs and multiple settings. Where do you dive in at? So can you walk us through what those do and how they generate their purpose? What's going on? Are the different valving, different oiling going on in that, or what's that knob actually doing?
We can speak on our behalf and what our single knob does. Our single knob controls rebound, and it controls low speed rebound. So that's how quickly the vehicle, the shock itself expands. And that's what our single knob does. For others, it might do compression only, or it might do a combination of both. But our single knob does slow speed rebound by itself. That's all it does. Our dual knob, that does low speed compression and low speed rebound. Low speed compression is going to be your smooth road type driving. Low speed does not correlate to the speed of the vehicle. That comes up a lot. It's the speed in which the wheel is traveling. So if you hit a pothole, that's high speed stuff. If you go over a dip and you're actually, now this does correlate. If you're going at a high speed, you're moving the mass of the vehicle over this dip. So it might seem smooth and slow, but you're still going to get into the high speed circuit of the valve. So with compression itself, though, our two knob does low speed compression, and again, that's all your steering response, your turning. I would say
steering feedback, or drag back.
How quickly you start to feel the road. That's all your low speed compression.
Would that be controlling more of the body at that point?
The higher the low speed compression, the more you're going to feel the road?
The higher the low speed compression, yes. And the higher low speed compression is, you're going to feel the road. You might have there's obviously dictates of spring rates and tire, but you're going to increase your steering response. But yes, there's limits to that though, because when that starts to get too high, you'll start to lose grip, and the tire, the mechanical grip of it just stops working. And so you never want to. More is not always better. You have to find that, and then try it in different conditions: wet, dry, and then Chris brought it up earlier, how are you using the vehicle? Because if you have if your turning response is quicker, but everybody who gets in your car hates it, then probably pointless to be driving around with that much compression all the time. Onto the 3 knobs though. The 3rd knob for us is your high speed compression. So that goes back to what I mentioned earlier. Those are your potholes, your dips. If you're on the track, that's your curbs.
Basically it's, again, I'm talking from a motorsports perspective, so everything in my head, I'm thinking racetrack, and he's thinking, street driven characteristics. But high speed compression is going to be basically curb strikes, fast transitions, so basically quick steering inputs. So in like a street driven condition, that would be something like swerving to miss a piece of debris in the road or something like that. Again, my own public service announcement is when we're talking about shock speeds, we're not talking about the speed of the vehicle, the actual ground speed or mile per hour. We're talking about how fast the shock is being either collapsed or extended.
Yeah, and if you ever get a hold of a shock in your hand, now, a lot of them are gas charged, so they're going to have some force just from the gas. But try to move a shock slow, and it's pretty easy, minus the gas force. Try to move a shock faster, and it gets harder. So it's that response of the wheel that I kind of talk about with speed, right? So the speed is changing, and I assume it's working different parts of the shock. Okay, we know what the knobs do, but when would we want to adjust them in what direction?
I think we kind of touched on what knob does what at this point, but maybe we can dive into why you would want to adjust each of those things.
Absolutely. But real fast, if people wanted to follow along online, see some of your products while we're discussing this, where do they go find your products at?
They can catch it at KW Automotive or KWSuspensions.com. Sorry.
Yeah, we've got Instagram, YouTube as well.
Okay.
By KW Suspensions or KW Automotive and either of those. We're KW_suspension on Instagram, and then the YouTube is KW Automotive. It encompasses the whole family of brands that
awesome.
we offer.
I'll give you all a follow right now. So, yeah, man, talk about when we use that stuff and how we use it, because a lot of people are, it throws them off a little bit when they're thinking about setting up suspensions. A lot of people, I think, tend to overthink it. But what are some of the first steps you guys would put out there as just good rules of thumb?
Yeah, so if you're kind of trying to figure out maybe where the best damper settings would be, kind of a general rule of thumb for some people is to start with the dampers at full soft, and then that way you can actually start to isolate how your spring rates and the car's pitching and heaving and rolling just off of the spring rates mostly, and not so much with the influence of the dampers. So then you can kind of pick up, okay, well, my spring rates are too soft, too on their own. From there, you can kind of get into your sway bars adjustments, because the sway bars are only active when you're turning, obviously. So again, we're kind of breaking this down from a pitching and heaving behavior. So pitching meaning that the front is diving and the back is lifting, or vice versa, the front is lifting and the back is squatting. And then you have heave, which is the vehicle moving up in a symmetrical fashion, up and down. And then roll, which is going to be left to right movements.
Okay.
And
I mean, that's some good advice right out of the gate. You get your springs and get your sway bars with, let's say, less influence by the shock by putting everything into soft. So you're kind of feeling out that and seeing if your platform per se is kind of where you want it to be. All right, so this is good. All right, so now let's say you've adjusted your bars a little bit. You got your car essentially getting more neutral, and you like the kind of spring rate, but yeah, now you need to get a little bit more control. So, all right, where do we go from here?
Yeah, so from there, my recommendation would be to start with compression. So you would start dialing in your low speed compression to start, and to kind of see basically, and you can figure this out just by driving down the road and just kind of getting an idea on how harsh the ride gets. To see, basically, again, we're kind of going back to that ride frequency that we spoke about in the earlier segments. And you can kind of, once the ride starts to get a bit harsh, you can kind of get a feel for where your limits are on the system as a whole. That's your tire, your spring rates, the vehicle weight, all that stuff. From there, you would move over to your rebound, and that's kind of going to help finalize those little bit of oscillations that you're getting, because the rebound's job is really to control the expansion of the spring, because the spring, when it's compressed, is storing energy, and then once it wants to expand out, it has all this energy it's trying to get rid of. And the damper's job, or the rebound phase of the damper at that point, is to control that energy and then convert it to heat. So that's how I would probably recommend starting. And that's on like a single or a double adjustable damper.
Well, let me pause you right there for a second. So if we're under rebound, where, let's say on a track, would you notice changes to rebound most? Like diving into corners, coming out of corners, whoops within the straightaways. Like, where would you kind of feel changes
off of bumps
to
and
rebound?
coping and curbs and things like that?
Yeah, I mean, so one way to tell that you have too much rebound is there's a condition called packing, which essentially is when you go over successive bumps and the suspension doesn't have enough time to expand back out. And that's when you have too much rebound. It's just clamping everything down, basically. And when that happens, the spring is also compressing. So the load or the force that the spring is producing is higher and higher and higher. And so what you'll end up doing is degrading grip, degrading ride quality, and so things like that. So what you would do is you would actually start to reduce rebound, and that situation would go away, or that condition would go away. If you get into we were kind of talking during the break there on drag racing and how you guys deal a lot with weight transfer and stuff like that.
Yeah.
It's the same situation in road racing as well. If you're coming off of the corner and you're starting to apply power, and it's a rear-wheel drive car, and the back wants to get skatey as you're applying power, you could reduce front rebound to help promote a little bit of weight transfer and get some grip there. Same thing entering a corner. If you're have too much pitch or brake dive, essentially, and the back of the car is getting squirrely, you could then increase rear rebound to keep the back of the car steady. Talking about compression with those same scenarios, if you have a bunch of brake dive, you could add front compression, again, to help that front nose dive. And if you're exiting in a corner with some, trouble putting power down, you could maybe reduce compression and see if that helps.
Yeah, man. You ever thought about a side hustle where you just get in people's car, drive it for a minute, and tell them what's wrong with it? Like, here's just jacked up. Here's what you need to do. Make 3 adjustments on rebound, add a little compression here, change the sway bar setting, have a nice day. That's $250 or $500 out the door. Roll on base 6.
Yeah, and you ever spend much time in Detroit? Because those two together would be great,
Yeah.
I think Chris kind of alluded to. There's multiple ways to skin a cat, and shocks with multiple adjustments give you just that. When you have low speed compression and low speed rebound, you're kind of you're using them to balance that behavior, right? And I think rebound is one of those things that is sort of, it's important for people to play with it, to understand the difference that it allows you to feel in the car. To me, in my personal experience, it seems like the more you start adding rebound, the more the body or chassis of the car feels more connected to the road, right? That's what I sort of use it for in when I'm playing with the shocks on my car or whatever. And then I'll use the compression to help with that sort of platform or stability, and then use it to dial in the behavior over bumps or curbs or things like that, But both of them are, it's important to not have too much, right? And that's the biggest thing. Like, one of the sort of, shortcuts that I would offer to people is loosen things up first and get the suspension moving, and then start analyzing the behavior that it's exhibiting, and then thinking about compression or rebound and which one is going to help your situation or help you alleviate whatever problem you're trying to dial out, but not net a terrible effect everywhere else on the track.
It's like getting your car out of detox.
Well, you guys broke it down pretty nicely, right? I mean, like you said, if you're coming into a turn pretty hot, you can nosedive and the back can come up. And like you said, you can either keep the nose from diving, or you can keep the back from coming up, and you have control on both ends, whether it's compression or the rebound. So that's kind of cool. And I like the way you guys broke it down into, starting softer, so you're really feeling the basics of the car. And at the end of the day, right, you can you can put too much in because what you're trying to do is keep your wheel in motion, right? You want that wheel to go through its travel. And if you put too much damping in, it's just too slow to get back to where it should be through its travel range. So that's when you start picking up some harshness, I assume, and probably chatter over certain types of bumps instead of rolling over them and keeping that contact patch.
Or just rent out Chris for a weekend. Just rent out Chris for a weekend and let him make all the changes. Like, boom, there you go.
Yeah, that's what I need. And then you go to a different track and you got to get them back out there again, right?
Yeah. That's how he gets you.
Yeah.
That's right.
It's a subscription service, Chris. It's a subscription service. All the cool kids are going to it. Wait, real fast before we run out of time. You guys probably see this a lot. What are some of the common mistakes that people are making when it comes to their suspensions, whether it's, on the track, road course, time attack? What are some of the things that you all see that people commonly mess up?
For me, it's probably making too many changes at once.
Absolutely.
Mm-hmm.
Can't keep record of what made a difference.
Yeah, exactly. And that's why, I kind of recommended that, you start with the dampers soft and you can help isolate things a bit. But they either make too many changes at once and don't know what was actually effective, what helped, or maybe they made a change that really helped, but they, did something else that took away some of the stuff that was picked up.
That's why a logbook, and especially on data like that, is always crucial. You always got to just know your settings, because one day you may walk out of something and realize, hey, man, it's a perfect scenario set up for that one setting I had. And if you can't recall it, especially from memory, if you don't have a log of it, you're kind of screwed. So keep a setting, logbook and what worked, what didn't, how the car reacted, and what the conditions were and temps were that day, and what your tires were, tread wear and air pressure. And man, you'll get a lot of data that you could really use and becomes really critical when you're out there hanging it out, man.
Yeah, to add to that too, Willie, I think it's important that people make changes to begin with.
Sure.
Everyone gets their shocks out of the box, and it may be 85, 90% there, but you may be leaving something on the table by not trying a little more or a little less, so it's important for people to get rid of the fear of making those adjustments and just do it.
Yeah.
You'll learn a lot.
Yeah. Like I said, I think, cause you're afraid to make it worse. And then where do I get back to? And if you take some good records, like Willie was saying, right? Just say, hey, this is where I'm at. I'm at level 2, 4, and 6 on my knobs. And then go play with it. And you can at least go back to 2, 4, and 6 and be back where you were. Not tangled up in a wad and go, man, how do I get out of this mess?
Right. Clean up aisle 6.
No doubt.
So secondly, okay, so obviously changing more things, than really what's able to detect a difference in. What's another mistake people might be making out there that you commonly see?
The next one would probably be too high on spring rates. Would probably be a pretty big one.
I think in general, spring rates, just not being able to pick the correct ones out the gate, or at least getting close. I think a lot of people look at their vehicle weight and that's how they pick their spring rate. And your vehicle rate's obviously important, but nobody's figuring out the motion ratio. They're not figuring out that wheel rate.
Right.
If depending on where the spring's located, if it's very inboard on the front of your vehicle and you have a double A arm style suspension and your vehicle is extremely lightweight, the spring's not seeing that. It's being multiplied by the lever arm, which is the control arm. And your vehicle could be 1,000 pounds or 2,000 pounds, but what the spring seen in that corner could be upwards of 2,500 pounds, depending on where it's at. And a lot of people aren't taking that motion ratio into account. They're saying, my buddy has this car and we're both 2,800 pounds. That's the spring rate I should use. But we have two different applications, two different chassis. And when you change the angle of your shock absorber with some coilover conversions, they change the angle of the shock absorber. So with your previous setup, you were running an 850 pound spring, but now that you've changed the angle of the shock, you don't realize it, but you've changed the wheel rate. So you try to put an 850 pound spring back on there and you say, this doesn't ride the same. It's softer. I thought I was making an improvement, or the ride quality changes. And you have to keep that in mind. So the spring rate is your base, your foundation. If you don't get that in, everything else is just a Band-Aid. So spring rate is very important.
Yeah, no, I think that's a huge tip. And as we talked before, I mean, that sets the foundation of kind of how your vehicle is going to behave. You're sort of adding bars and dampers relative to that spring rate. And as you mentioned, right, if you didn't quite pick up, if your spring was right center of your tire, right, standing straight up, that's your wheel rate. But your spring isn't there. It's got an angle to it, maybe. It's got a position relative to that tire. And so that little bit of geometry, it's pretty simple. But that little bit of geometry can mean a lot on doubling your spring rate or other. So how does somebody kind of get that right? Can they call you guys up and say, hey, I've got this application, it's either stock or I've modified it, and I want it to be in that, street, track, race kind of range for wheel frequency? Can you get them dialed in appropriately?
So I mean, outside of our normal offerings, which, obviously a lot of engineering and time is spent on getting each of the off-the-shelf products dialed in for the majority of customers, you can call us and we can build a completely custom solution for you. So, and that all goes through the KW race department, and we kind of start from scratch with you. Yeah, what are you using the car for, and weights, motion ratios, dimensions, ride heights, roll centers, all that stuff. And we've done stuff from Ferraris to 69 Camaros and everything in between. So C10s recently, yeah.
But trucks are killing it right now, man. It's crazy to see the surge in those things popping.
Yeah, but a lot of C10s, man. Yeah, no doubt. Yeah, you guys got to check them out online, man. They have a huge selection, and it sounds like they can kind of get in that custom space too, if you need to go there. Yeah. But I'm assuming they probably have most of the world covered. So whatever you need, man. And they got a lineup that's incredible, from your classic stuff to coilovers to, even into your dynamic damping control. So we'll have to dive into some of those technologies maybe on the next time. Appreciate you guys being on.
Yeah.
Thanks for having us.
There you guys go, man. Appreciate it. And KWsuspensions.com, is that where you said people can go find you guys? KW Suspensions?
Yep, that's it.
All right, man. Sweet. Find them online. Check them out there. Check out all the cool stuff they have available for your ride. Hey, and don't forget about our show, air weekends on the Motor Trend Network. Check your local listings. It's also available on Motor Trend Plus, which is a streaming format, a great way to find us. Thanks to our guests, KW Suspensions, Frank, Chris, and Joseph. Joseph came in with home runs at the end there, man. Nice cleanup there, Joseph. We appreciate it. And our producer, executive producer, Bob Becker. He's Kevin Bird. I'm Willie B for the Two Guys Garage podcast.
Yeah, don't forget to check out our website, twoguysgarage.com. Share your thoughts with us. We're on social everywhere, Facebook, Instagram, and Twitter, at Two Guys Garage. And this Two Guys Garage podcast, it's copyrighted 2023, Breton Productions Incorporated. All rights reserved.
Man.
On, man. You got some good
I took more notes today than I did in all of my algebra class. Look, man.
I got me some too.
Yes.
All right. All right, gentlemen. We appreciate it. Hope you guys learned something. I know Willie and I did, so we'll catch you on the next Two Guys Garage podcast.
Thanks, guys.
Thank you.
Awesome.
Thanks, fellas.
Appreciate it, fellas.